Here are checkpoint 1 directions. What do you need to do to get green on this checkpoint? As always, you're going to check this summary box so you know what to turn in. This box will be at the top of every checkpoint for the entire year, and if you have me for another class next year, it'll be there still. So you are going to make sure you fill in your example practice problems. We'll do those together. You'll practice some on your own, but we'll double check. So these will all be correct in the end because we'll make sure of that. If you end up doing this in makeup or on home, as long as you get half correct on your own, you'll get credit for that section. Then there's a model box. Remember, if you click on these words, it'll take you right to there. So this model box is 3 sections you have to do. And notice there's an optional question. If you do this, you can get an A level on this type of cognitive skill. And last but not least, there's an energy explanation box where you're going to answer these 2 questions. And this question is broken down into 4 parts to help you answer it. And obviously, we have our optional higher score questions. If you do either one, you'd get a B. In both, you could get an A if they're correct. So let's go back to the top. In these, well, actually, first, you're going to want to read this. It's a good background, it's a good review, and it helps you answer one of the questions you have to do later down where we just were showing you those questions. We are going to practice making energy diagrams. And if you remember from our note guide, energy diagrams are basically words or types of energies with an arrow to another type of energy to show how energy changes from one form to another. Remember this law? Law of conservation of energy says we can't make or destroy energy. The total stays the same. What happens is the type of energy changes. So when you're doing some of these on your own, I'll show you a practice one together and do one for you. But when you're doing these on your own, if you forget, I don't know what kind of energy humans have inside them or start with. Well, read through these 6 hints. Humans have chemical potential energy when it starts with human energy. That's from our food. When something falls, it has gravitational potential. Each of these, if you're stuck, these hints will help you with most of the answers. So here's a demonstration problem, so I'll show you what we're talking about. It says a roller coaster goes down a hill. You have a sentence, and we need to convert that sentence into a energy diagram. So we just have to figure out the first step is what kind of energy would a roller coaster car have on the hill? Before it goes down, it's on the hill. What kind of energy does it have on the hill? Well, if we remember, great. If we don't, we look up here and read through these. And number 2 says when something falls, it starts with gravitational potential energy. All right, the roller coaster falls down the hill, so it starts with gravitational potential energy. When the roller coaster is going down the hill, well, the gravitational potential energy is going down because it's not as high in the air now, but it can't disappear, so it turns to something. So to show it's turning, we put an arrow, and then the car is moving faster and faster down the hill, so that is kinetic energy. And oftentimes in these problems, you're going to have a second blank past that arrow. You're like, well, what could it be? It's on the hill, it's gravitational, it goes down, it's kinetic. What else is there? Almost always that other thing will be thermal energy from friction because things touch. In this case, the roller coaster wheels touch the track. So when in doubt, pick number 6, thermal energy. All right, number 1 I will do kind of for you, but hopefully you do it the right way and try on your own. So it says a human eats food and then goes for a run. All right, so we have to think, what kind of energy do we start with when a human eats food? So press pause and try to do one by yourself. All right, if you don't remember what kind of energy is in food, if we go back here, it says things that start with the human body are chemical. So I would write chemical in here. Then goes for a run. Well, if you're running, you're moving. And just like the roller coaster car moving, anything moving we said is kinetic. Seems like we're done, but we have that other blank. Oh yeah, I said if there's another blank, it's always going to be thermal energy. So that's how you do those. You'll try 2, 3, and 4 on your own, and you'll turn those in. When you're done with that, you're going to click this simulation link, and this video will show you how to work it, so I'm not going to waste time in adding it to this video, but you'll click this link, and this video will tell you how to work the simulation. And in the simulation, you'll see an example. In the example, we go over here and in the video together. So we have our sentence and setup. Here's the water. Here's the wooden wheel. Here's the water over here. And then the change of energy is going to go from mechanical to electrical to thermal, but you'll see that in the video if you don't understand it, since I'm going kind of quick in this short video. Once you are in that simulation, the directions will say set up these setups in the simulation, which I show you how in the video. So this video had water, a wheel, and water. Well, that's fine. You do that, and then you're going to change it to sunlight, solar panel, and light bulb. And if you look, there's sunlight, solar panel, and a light bulb. So you'll just change those and then record what kind of energy does it start with and change to in the video. So you might not know these, but they'll show you in that simulation, so the video will help. Then you'll set up this one, teapot to wooden wheel to light bulb, fill in your energy transformation, bike to wooden wheel to fan also. Last but not least, we go down to the bottom. Number 1, in the last setup you did in this box, the bike wooden wheel fan, it says, what type of energy did chemical energy come from the biker turn into once she got tired? So you're going to run that simulation and look, and it'll give you the answer. Then it says pick any of your examples from the model box, so any of these 3. What you're going to do, say I pick number 3, copy and paste it with your answers over there, and that will answer these 2 questions. So if you copy and paste it, that actually takes care of both of these. Then it says define the law of conservation from our notes or Energy Basics Objective 3 slideshow, or if you click here, it'll take you to a reading that has it. So put the law of conservation in your own words, or if you take it from our notes, you can copy it straight from our notes. I don't consider that cheating because the notes are all of us working together. Last thing you're going to answer, tell me what happened to the total amount of energy in your simulation. Did it go up, stay the same, or go down? And if you're not sure, the answer is actually in your definition from this part of the question. So it'll take care of that for you. Then you're all good to turn in checkpoint 1.